So what we now have to do is to make sure that the geometry mesher, so the part of the engine that creates the geometry for the entire game world, has access to lighting directional information. So let's open up the client chunk. We have lighting information stored here somewhere. Yeah, we have light values and we have light data. We should also store where light is coming from. That's client chunk 3D data. And we store cell coordinates as well. Light data positions. Sure, because once we know the positions of the light where it's coming from, we know the position where we're rendering from, and we can calculate the vector. Let's open up the light value tracker. This thing updates light values for coordinates. So we never darken light. If the new light value is smaller or equal to the old light value, we stop. This update method, we're going to include not only the new light value, but also a cell coordinate 3D, new light coordinate. I like to use const a lot, so let's const these up. Const means that this value is fixed, can't change. So we never darken light, that's good. And if we would darken light, we don't have to update the light origin. Shall we call it origins? New light origin. There are two hard problems in computer science: caching and naming things. Okay, light origins, there we go, light origins, that's entirely what we want. And we might even want to rename them in the client chunk as well. Light origins, like this. We filter out light that is darker than what we already have. But if light is lighter than what we have, we not only want to update our light values, but the light origins, we set the in-chunk coordinate to the new light coordinate. And new light coordinate is actually renamed light origin now. New light origin, new light origin. Now we go back to the light value renderer and we go to the setup light origins. There's a lot of compilation errors here, but we're going to fix them. Set up light origins. This is where we set up the initial values. So we know the origin of this. So we do cell coordinate 3D, const, the origin, that is the base x plus x, base y plus y, base z plus z. Because as you can see here, we are looping through like the size of a chunk. We have the base coordinate of our chunk in base. So we can just calculate base x plus x, base y plus y, and base z plus z. And I'm a bit of a parentheses dude, so let's add these around it. And we now pass in the origin plus the maximal light value at each of the cells that has a light source. We're updating the in-chunk coordinate with the propagated light value from our neighbor. And now we just need to know where the light came from. Oh, we have a cell data provider, okay? So now what we want is light origin, and that's cell data provider, get light origin, light source, neighbor coordinate. So now we need to create cell data provider, get light origin. Let's just copy over what we do for the light values. We get the client chunk for this coordinate. That's a good starting point. If we have a chunk, return the light origin for the requested coordinate. So in chunk coordinate, it's const, and then return chunk get light origin. Origins, data origins, get in chunk coordinate. Apparently we do not know this chunk, so we could return an empty coordinate, of course. So we should be compiling, the light value tracker should be working. Okay, so I'm not sure if we're leaking memory, but we can at least now try to see light value tracker, caveman style, printf, sure. Updated light at d. Oh, look at that, it's working. So these are in-chunk coordinates, and these are actually the in-world coordinates, and they look very reasonable. This is level 1, this is level 2, 3, and 4, so that's actually correct. The fact that we're updating multiple in-chunk coordinates with the same origin, as you can see, that's cool. So okay, we have a chunk light value renderer, and we have a chunk light data renderer. Data renderer is the thing that renders the data towards the chunk, and the value renderer is the one that like renders values that we are going to store later on. So we have all of the data here, and we loop through the whole chunk. Okay, so here we can actually start comparing like which light is the lightest one. Let's make it easy on ourselves. UN32T, brightest source is artificial. if brightest source is smaller than infrared, brightest source is infrared, and the origin becomes the source infrared, and if brightest source is smaller than ultraviolet, then the brightest source is ultraviolet. We don't actually use this, and the origin becomes the light origins array. Ultraviolet, and then we store brightest light origin if we have any light. If 0 is smaller than the brightest source, light origins, data origins, set in chunk coordinate origin, and else, so if we don't have a light source, we just reset it to be empty in chunk coordinate, cell coordinate 3D. So none of the origins that we are currently propagating or updating are either empty or 0. So that means when there's a little bit of light striking somewhere, we always have a proper origin saved. Then what we want to do is we want to look at the client light color provider. This is what it gets called for every vertex in the game world. We want to update the lighting nice, this thing, and it gets called on a vertex, and we have a cell data provider. Sounds familiar. So this is where we interpolate light data. This is actually what we want to do, kind of, sort of. I can live with doing a single sample at the moment. Our task here in this function is to update this model vertex. And remember, this vertex, model vertex, now has a lighting direction. The lighting direction is the normalized vector from the light origin minus where we are. Origin subtract position. Position is the actual world position. Now it's only a matter of getting origin. So const cell coordinate 3D light origin. And we want the decimal vector from center of light origin. So this makes sense, right? We take the center of the light origin, which is what we've calculated from the flood fill. We take our vertex position, and then we subtract our position from the light origin. It's simple, it's 3D programming, it doesn't have to be perfect first time. We just have to get the light origin. It's the cell data provider, get light origin, and let's just say that we have a sample position. This is going to work, enjoy. Hey, check it out, here, there we go, boom. See it, see this, see this? See this, it's actually reflecting the lamp. It's working exactly as intended. First try. See this? Wow! See the directional lighting on these? What? I'm going crazy. I'm going crazy. Check it out. This will make... What? 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 This is looking like a ray tracer almost. Check out the lighting quality on that. We now have an infinite amount of light sources.